Okay, welcome to the video. Let's do challenge number 61. So this challenge, if you ever seen the movie Martian, that's what the challenge got inspiration from. So they have a quite a bit of a text to read. The general idea is when Matt Damon in the movie The Martian got stuck there, they can only transmit signal back to the Earth through some kind of rover. And the rover, the only thing it can do is really rotate. What you have, let me run the workflow. What you have is you try to use a hex code system. So that means you can have 0 to have 16 characters. And with that, the hex code use the two-digit hex code that can encode a long list of informations. So we can see here we have your regular decimal. We'll probably go to the letters. Yeah, something like this. So what we can have is our capital letters, the corresponding field, and the field. Then you have the corresponding hex code. So it's a combination. Hex code, you have 16 characters, 16 times 16, so you get 258. That's how much combination you have to cover all the sense of message. So for us, suppose we have some kind of message we want to send from the Earth to the Mars or vice versa. Each letter you traverse will belong to one hex code. We're looking for how you do the traverse and how long it takes the message to be sent. Additional information they gave you is we're going to have 360 degrees. You split into 16 hex code. So each will be some kind of, I think, 22.5 degrees angle. Then you try to find the smallest root. Now, for this, let's start the workflow again. So let me get rid of this as well. The final answer is we're looking for how long the whole message will be traversed in terms of both seconds and in terms of minutes. First thing first, we'll look at the input for the cards. We don't really care the first question, we really care from the rest. But we have 16, so in the decimal system, it's not easy to label. We're gonna do, yeah, let's for example, let's give it the first one. I want I want to have a record ID for the input. So for us in the decimal system, we can keep track every single character. Now for then, let me check record ID straight after. You expect 60 of those. Let's start with 0. We'll see the reason for that. So you can see 0 to 15, 16 rows. Each of those will follow certain order, go through 300 degrees, 360 degrees for the 4 revolution of circle. So we can want to decide at which angle, which position they are corresponding to. So let's call that angle. Angle is basically we can use record ID, which is integer at the moment, times. We can do the math 360 divided by 16. So each of those should give you 22.5. So we can see we produce a list. Because we start to say 0, the first character in the hex code, we're going to start with 0 degrees. The next one, you traverse the 22.5 degrees, etc., etc. So we can see the last one, 7.5. If you do one more, 22.5, you back to the 360, which is 0 degrees. Okay, so that's the input is done. Now, the response message. What we have, the message is we send it to us respond back to us. From the respond message, we want to decode. To decode any particular text, regex is my favorite choice. So I can select them to decode by every single character. We're going to pass. So we're going to tokenize 2 rows. Generally, you don't know that if you don't know how many you're going to get. 2 rows is always the best choice. Because we change the position, we got to make sure through a record ID just in case, make sure we preserve the particular orders. So that should be that. Hex table. The first row is the header row, so let's dynamically rename to bump that up. Dragging the row. So header, let's run the workflow to check every aspect of the data. First row is fine. Symbol will be the reference column we're going to use. Then the hex code is the one we're interested in. So with our data, they even have a space. Even a space has the corresponding hex code as well. So it's the dot in the very end. Let's do a let's do a join field. In this case, you can find use find and replace as well if you wish. But I'm not going to worry too much about it. Symbol. Let's the response. Response they join on the symbol, so the hex code we're interested. From the output, we'll see now because the join any purple tools usually mess up the order. It's okay. So 17th row should be N and corresponding hex code is 6E. 6 goes to 6E, that still is not good enough yet. We want to split one more time. Let's try text to column. You can use regex again, but text column does the job as well actually. Hex code delimiter, nothing. Can we do that? Let's see. They don't accept. Let's be safe. Regex. So we're gonna do. Let me add a sort first. I want to make sure my order is correct. Otherwise, you regex split to rows, you lost the correct positions. If you try to sort, you don't have a way to tell the first and the second, just to be safe. So record ID ascending, we're gonna regex on the hex code this time. Same thing, we're gonna do a single character. What we try to do, we're still gonna tokenize 2 rows. Okay, that's pretty good. The V is 57, W is 57, E is 65. Now we kind of need to do group by ID. So for me, that's tiles 2. You can choose one group by record ID, smart tiles, number column down. Should be fine, I guess. Let's see. Yeah, let's not worry about the tile number. Tile sequence is the one we care because that helps you to keep track 1212, the first digit of the hex code, the second digit of the hex code. So we have our message decoded and sorted in good order. With that done, we can start to do some kind of drawing for each positions. Let's look at hex code. We compare to our initial input. That's the angles corresponding to it. So more drawings. Left hand side, we keep, let's disable record ID. We want tile sequence. That's like the hex code order we care about. Response, it's fine. We got replaced. The actual hex code is the one we want. The right hand side, we're gonna join on the hex join on the cards. The right hand side, I want to care about the angles. Good. Sorting one more time. Record ID, tile sequence, sort. Da, da, da. So record 81, tile sequence. So remember the first letter is W. So capital W is 57. The second character is lowercase e, which is 65. We got the angles, that's fine. That means we can start doing your multi-row calculations. So we want to see each step, how that camera angle should move. Speak of this. Okay, so we're gonna create Let's see, travel. Let's say two travel. Because we have decimals, so let's call that double rather than decimal. Every time we're gonna single. Let's do some trigonometry. We have here the straight lines. That's your Cartesian coordinate system. If your first angle, 1, your second angle is here, 2, we looking for the second angle minus first angle. Now we don't care the direction, not specific the directions. We're going to just care the absolute difference between those guys. So if they're less than 180 degrees, yes, we'll take it wherever the difference is. On the other hand, let's go back. Say they may have something like here. If you do standard mass by convention anticlockwise, you get an angle that's bigger than 180 degrees. We're going to do probably 360 minus. So we are effectively taking the other parts of the angle. Okay, so with that logic, then let's do some math. If statement. Oh, I do think we'll probably need to worry about the first angle. What did they say about the starting position? So we're gonna assume camera starts on the question card and ends on the last letter. Question card. Not entirely sure the exact way they want to do it. The last question card, are you stay on the question mark itself? You have a hex code for question mark, then you have 2 digits. Do we finish the last digits of hex code? Or you have, let's see, yeah, you have some special characters involved, like a start of transmission, end of transmission. So as this thing gonna start on the symbol is COT, hex code is number 4. Is that gonna start on number 4? Huh. That's fine. We'll not worry too much about it. I think the final answer is very close. It's not exactly the same, but it's probably just to do with the starting position. So for us, we on the top we choose for y doesn't exist to be 0. Let's assume your camera start on the 0 degrees. Then let's traverse. If I wanted the absolute value, the difference between my angle 2, so that's my current angle value minus your previous angle. So the difference, if it's less than equal to 180 degrees, we're gonna keep this difference. If it's bigger than 180 degrees, we're gonna do 360 minus the difference. Okay, let's see. So, why give me -1? Is angles? Yeah, angles are double. Oh, sorry, group by. We need to do some group by. So for each, no, we don't need group by. You just need to sort it. You need to traverse it. What's wrong with my logic? If my angle minus, so angle is the current row, that's the position move 2 minus the previous one is less than 100. So the first one, you take a difference. You're getting about by 45 degrees. It's less than 40. So you should return 45. Else, that's weird. What's wrong with that? Angles, 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 angles. Yes, directly. So my current angle minus my previous angle, current and the previous, the difference, absolute value of the difference is less than 180 degrees. Then give me the value. Let's just test the zero. Let's get a calculation right first. Hmm. Maybe the natural. So I'll post the video for a minute. Let me check my errors. Very confused with myself. So instead, I'm going to do the other way of doing it. What I'm intended to do, let's put zoom in here. We're going to do as a minimum of the two value. So either you do clockwise or you basically do anti-clockwise. You take both angle to see which is the smallest. We'll try to traverse through the smallest angle distance. So if we're looking from the second row to first row, they differ by 45 degrees. Yes, we'll travel 45. 135, you're moving technically back negative 22.5, but we just care about the absolute value of the angle traveled. Each stage will calculate the to travel. Now, once that's done, we can start to calculate the total angle in the travel. So to travel, we want to aggregate. So the total angle you can travel is that. Okay. Now we do have one more data. That's about the camera turns. So it's angular speed for the camera. You can use four. Rather than do another drawing, I'm going to be a bit lazy. Let me just use four for the formula. You can do drawing. Let's pretend you have a different camera settings. You may have different speed. You may want to change. Depends on kind of input set. Because the units is 4 degrees per second, we have our total sum divided by 4. That should produce how many seconds you need. Once that we know the seconds, the next choice is minutes. So MI and UT, let's put S in there. Seconds, that's how many seconds you have. We need to divide by 60 minutes. The last one, let's change it to double as well. For us, the mass calculated 2,400 seconds, about 40 minutes. So 2,000, not entirely sure why the answer is a little bit odd. So they have 24, 35. 24, 35, they have additional 35, additional 17 degrees. Not entirely sure where that 17 degrees come from, though. But nevertheless, the answer is close enough. We have an estimate 40 minutes for the entire message to transmit. Assume you don't take any additional standard transmission, stop transmission, start transmission, those code as well. Just the message itself, it take about 40 minutes. So it's quite fun. Little exercise we was using various data source, try to link up to get our results. And that is the challenge. Thanks for watching.